So before this video starts, I just want to apologise. The audio to the first half of it got corrupted, so it just never recorded in the first place. So it doesn't have audio. If you scroll, when you're watching it though, everything is explained in it though. Actually, get rid of that. Throughout the whole video, there is writing and everything, so you should still be able to follow it. Any questions though, just let me know and I'll get back to you as soon as I can. But it's only for the first question. For the second question, which is coming up in a second, this does have audio. So the second part, which is arguably trickier, there is audio for, but unfortunately there isn't the first one. So if any questions on it, just let me know. I'll get back to you as soon as I can. So we're going to be looking at this question 8 now. So, a rectangle is inscribed in a circle of radius 5 units with centre O at 0, 0 as shown below. Let or xy be a point where x and y are real numbers, and let it be the vertex of the rectangle in the first quadrant as shown. Let theta be the angle between O and R and the positive x-axis, where theta is somewhere between 0 and pi over 2. Part 1. The point Rx can be written as a cos theta, b sin theta, where a and b are elements of or. Find the value of a and the value of b. So, first thing we're have to know, if you look at your tables, this point right here, any point on a circle can be written as the cosine of this angle right here, sine of angle right here, where the cosine is going to be your x coordinate and your sine is going to be your y coordinate. So, keeping that in mind, the only thing this doesn't tell you is that because this circle here has a radius of 1, that these are both multiplied by 1. So this is 1 cos A sine A, or 1 cos A, 1 sine A. So whatever this radius is, that's what we multiply it by. So in this case, what we have, if you can see here, is a radius of 5. So what we can do is we can say that the point or, xy, is going to be equal to 5, which is the radius, times the cosine. We don't know the angle, but we don't need the angle. So this is just going to be 5 cosine theta, comma, or 5 sine theta. So our added values of A and value of B is going to be 5. Part 2. Show that A theta, the area of the rectangle measured in square units, can be written as A theta is equal to 50 sine of 2 theta. Well, if we think about it, the radius is just going to be half of the length. So what we need is going to be the full length. So it's going to be double that. So how would we write that? We'd write that as A theta is going to be equal to 10 cosine theta multiplied by 10 sine theta. Multiply this out, we're going to have 100 cosine theta sine theta. And now we need to start thinking about when do we get a double angle inside of it, because that's what this question is about. We have a double angle inside this sine function right here. Well, again, if you look down at your tables, the second page after you see all these values, we're going to have some double angle formulae, in particular the sine function right here. So the sine of 2a is equal to 2 sine a cos of a. So that's what we're going to use. So if we come back up here and just note that, we know that the sine of 2a is equal to 2 sine a cosine a. And what do we have here? We have 100 cos sine. So even though in the blue it says sine cos and in the black it says cos sine, they're commutative. It doesn't matter which way you put them. It's the same as why 5 multiplied by 2 is the same as 2 multiplied by 5. So we can rewrite this as 50 multiplied by 2 sine theta cosine theta. And then we can replace the 2 sine cos by the sine of 2a. So this is just going to be 50 sine 2 theta. And that's how you show that. Now, going in here, use calculus to show that the rectangle. I'm not going to do this question just because you're probably not going to be asked it. Because you haven't really touched differentiating trig functions just yet, because it involves the chain rule. So, and the last one as well, it involves calculus as well. It's a very abstract question. This type of question rarely gets asked, so I don't think it's going to be too beneficial for you. Because it gets a bit complicated. But anyway,